You just cut that part out, right? How Denisovans Fit into and Impact the Timeline of Human Evolution by Thomas Lee. So I decided to do this topic because I was really interested in the way us modern humans have come to evolve and how we got here today, and what our ancestors were like and all the differences between them and us, and all the branches that have come and passed and that led to ultimately our arrival. And so, yeah. So this is just an artist rendering of what Denisovans would have looked like when they were alive. And as you can see, there are obvious cranial differences between them and us. And so our first topic will be the Denisovan time period. So they most likely split from ancestors of modern Homo sapiens around 700,000 years ago. And at that time was the middle to late Pleistocene. There is no general consensus placement of Denisovans within the human evolutionary timeline, but they are thought to be cousins with Neanderthals. So from that same split lineage that split and gave us those two groups, and they split themselves with Neanderthals around 400,000 years ago. However, this point still remains in contention. So here you can see one interpretation of the timeline. And as you can see, from about 330,000 to 250,000 years ago, we had the earliest stone tools. And then a little after that, around 220,000 years ago, the sediments with Denisovan DNA were found. And a little after that, earliest sediments with Neanderthal DNA were found. And as you can see, the earliest Denisovan fossil was also found before the earliest Neanderthal fossil at around 200,000 to 120,000 BC. And the latest Denisovan fossil was also found after the latest Neanderthal fossil, and that would be around 75 to 50,000 years ago. So that last point about how Denisovans split with Neanderthals around 400,000 years ago, and split at the same time from the overall human ancestor around 700,000 years ago, that's still in contention. There are indications such as differences in mtDNA that may place Denisovan split lineage prior to those of Neanderthals. And this lineage is currently extinct, but they may have bred with modern humans as recently as 15,000 years ago. So how was the first Denisovan fossil discovered? It was first discovered in the Denisova cave, aptly named, in Russia in 2008. And it was discovered by Russian archaeologist Michael Shinkov and his team. And the first fossil was a finger bone of a juvenile hominid, which was referred to as the Denisova woman, also known as the X-woman. And here you can see a picture of the Denisova cave. Obviously, there have been excavations made into the cave and its many branches, and it has yielded a lot of evidence for different subgroups within the evolutionary timeline throughout the cave. So not only were fossils found within the cave, but so were other objects such as artifacts. And these artifacts were from various time periods, including the Acheulean industry, the Mousterian industry, and the Levalloisian industry. And these presence of artifacts indicate that the cave was inhabited up to 125,000 years ago by modern humans, Neanderthals, and Denisovans at various times. So not only did Denisovans occupy this cave, but so did other subspecies at various times within this timeline. And one notable artifact includes a bracelet dated to around 40,000 BP, which is before present. And here you can see a picture of the artifact, and you can see it's very well preserved, and it's provided a lot of evidence for the time period that was found within this cave and the types of subspecies that were living there. And other fossils and specimens found within this cave. An upper third molar belonging to a young adult was found, and it was dated to be around the same time period as a finger. And they were found near each other within the cave, indicating that they probably lived pretty close together. The subspecies inhabited the same zone within the cave. And a partial mandible of a specimen was found on a Tibetan plateau, and it was found by a Buddhist monk in 1980. But it remained unstudied in Lanzhou University in China until 2010. And recently, it was determined to be closely related to fossils found within the Denisovan cave, placing them in the same family. And that mandible was dated to be older than 160,000 years old. And it was only in 2019 that it was declared a Denisovan fossil. And here you can see a picture of that mandible that the monk found. And it's only a partial mandible, so it's not the entire thing, but nonetheless, it's a very important discovery. Dating methods. So a finger bone was dated using the sequence mtDNA. That was the finger bone of that juvenile hominid. And that upper third molar found near that finger bone was also dated using mtDNA. And they were found to have existed roughly 7,500 years before the finger bone. So they were very closely related, and that subspecies probably inhabited that cave for that amount of time at least. And radiocarbon and oxygen isotopes were used for dating artifacts found within the cave, such as the bracelet. And protein analysis of collagen within the partial mandible discovered on the plateau. That was how they found it to be very closely related to the Denisovan cave fossils. And uranium decay dating determined that the mandible was more than 160,000 years old. So this places it very closely within the Denisovan lineage. So what about Denisovan's overall place in the human timeline? As we said before, there is no definitive place within this timeline. It's very hotly contested. Dating methods have found no conclusive evidence of where Denisovans should be placed. There is very little evidence for each way. There are very little fossils and other pieces of evidence that have been found to really conclusively prove one way or the other where Denisovans split and what happened within this very large time frame. But some anthropologists believe that Denisovans emerged from Homo erectus, and that was along with the Neanderthals around 550 to 400,000 years ago. And they named this split subspecies Homo heidelbergensis, and that makes Neanderthals and Denisovan sister groups, if this interpretation is correct. And Denisovans may have split from Neanderthals around 300,000 years ago in the Middle East. That is where the evidence is currently the strongest. But other anthropologists claim that Denisovans have split long before Neanderthals, up to 1 million years ago. And they also may have been part of an earlier migration out of Africa than those of modern humans too. So connections to other subspecies. They were found to have bred with Neanderthals. They have a lot of mixed DNA, and we have found a lot of evidence indicating that. They have also bred with modern Homo sapiens, and the last interbreeding may have been as recent as 15,000 years ago, which is very recent in the overall timeline. Some people in East Asia and the area around it have been found to contain 3 to 5% Denisovan DNA, and it's most abundant in the Melanesian population, where they contain actually up to 4 to 6%. Denisovans, however, as a distinct subspecies, are completely gone. They're extinct. They no longer exist. And here you can see a picture of Melanesians, where they found the strongest evidence for Denisovan interbreeding. So in conclusion, Denisovans are a subspecies that branched off the evolutionary timeline of modern humans, and that at which point is very debated, and there is not enough evidence to conclusively say one way or the other. We can see, however, that they are more closely related to Neanderthals, and only a few specimens have been found, so not that much evidence, and no scientific consensus on their place in the timeline of human evolution. Their existence, however, paints a vastly more complex picture of humanity within the middle to late Pleistocene than previously thought. Makes everything a lot more complex when we can see how diverse our lineage truly is. And that's it. Thank you.